Okay, here we are on page 5 and 6 of sequences and series. A sequence is geometric if each term can be obtained from the previous term by, and just to give you an example of a geometric sequence, we can give here 1, 2, 4, 8. Okay, so how do we get one term from another? We multiply. Okay. In a geometric sequence, the blank term is always the blank of the blank and the blank. Now this you have to get out of the book. No one's ever going to guess this. Okay, basically the word geometric sequence comes from the geometric mean. So before we said in an arithmetic sequence, the middle term is the arithmetic mean of the previous term and the next term. In a geometric sequence, the middle term is always the geometric mean of the previous and next terms. Okay, so this is the equation that you can use to find out what the general term is, the nth term, based on the first term of the sequence, the common ratio, which is r, and the index, which is n. So if you know those three things, you can figure out the value of the nth term or the general term without having to calculate every single term in between. Okay, so for the geometric sequence 2, -2, 50, -150, if un is -250, let's say that's un, okay, what are u1, n, and r? Okay, well, let's see, u1 is the first term, it's 2. N is the index, so if this is term 1, this is term 2, this is term 3, -250 is term 4, so n is equal to 4. Now what's r? R is the number that you're going to multiply for one term to get the next term. So for example, 2 times r would be equal to -10. So what's r? R would be -5, right? So you can see that every time you multiply by -5, you get the next term. So 2 times -5 is -10. -10 times -5 is +50. +50 times -5 is -250. Okay, so those are the three values for the variables. Okay, next part. Check out example 7 in the book. Okay. For the geometric sequence with the first two terms given, find b and c. Okay, so remember, in a geometric sequence, we're always multiplying by the same thing. We're going to do a and c here. So to get 6, we would multiply times 3, right? And then to get, and then we take 6 and we multiply by 3, and then we'll get the next term, which would be 18. So b would be 18. Okay, and then we would multiply 18 times what? Or times 3 again, and then we're going to get the next term. So that would be 3 times 18. That would be 54. Okay, so c would be 54. Okay, so basically we have 18 and 54 as the next two terms. Now c is a little bit trickier. We're going to take 12 and we're going to multiply it times some common ratio, r, and then we're going to get -6. Well, what is r in this case? Well, you can easily find it by algebra. We just divide both sides by 12, right? And then so that means r is equal to -1/2. Okay? So if r is -1/2, now the multiplication is easy, right? So 12 times -1/2 is -6. -6 times -1/2 would be +3. And +3 times -1/2 gives you -1.5. So those are the next two terms for that one. Okay, for number 2, we're going to do this one and this one. Find the sixth term in each of the following geometric sequences. Now in this case, they're asking for the sixth term, not the fifth and the sixth. So we could use the formula, right? We could say u6 is equal to u1 times r to the n minus 1. And of course, n is just 6, so that means 6 minus 1 is 5. Okay, so we just need to figure out what to put in for r, because u1 is obviously 3. What's r? Well, it looks like we're multiplying by 2 every time, so r would be 2. So it would be 3 times 2 to the 5th. So you just need to multiply that out with your calculator. C, we have U6 is equal to U1 R to the 5th, right? So U1 is just 512, right? And then R, let's see what R is. Well, what do we multiply times 512 to get 256? Well, it might be kind of hard to see. It's either 2 or a half. We don't know. Well, if we divide both sides by 512, it'll be clearly 1/2, right? So R is actually equal to 1/2. So you could just multiply that on your calculator. Very easy, right? 4, let's do A and B. Show that the sequence 5, 10, 20, 40 is geometric. Well, all we need to do is show that multiplying 5 times a number, in this case it's 2, gives us the next number, which is 10. Multiplying 10 times 2 gives us the next number. And multiplying 20 times 2 gives us the next number. So it is a geometric sequence because we can find the next term always by multiplying by the same factor, which is the common ratio. Find U sub n, and hence find the 15th term. Okay, so U sub n is equal to, and when I say U sub n, that's U subscript n. First term times R times n minus 1. So that would be, let's see, we just need to fill in the numbers here. So U1 is 5, and R we know is 2. Okay, so that's the general term. Now, what if we were looking for the 15th term? Then we would look for 5 times 2 to the 14th. Okay, so you could just put that in your calculator to find that. 6, show that the sequence 8, negative 6, 4.5, negative 3.35 is geometric. Okay, so let's see. It might be kind of hard for you to see what the common ratio is here, R, but 8 times R would be negative 6, so we could just use algebra to find that. R is equal to negative 0.75. Okay, so once you know that R is negative 0.75, now it's easy to find the 10th term, because the 10th term is just equal to the first term, which is 8, times R, which is negative 0.75, to the n minus 1, which is 9. So you just put that in your calculator. Make sure that you put the parentheses in the right place, and then you'll be fine. Let's see, 8. We're going to do A and C. Find K given that the following are consecutive terms of a geometric sequence. So we know that 7 plus R, or I'm sorry, 7 times R is equal to K. And we know that K times R is equal to 28. So we could combine these equations, because we have 2 equations and 2 unknowns. So let's see. R is equal to 28 divided by K. So 7 times 28 divided by K is equal to K. So we have 7 times 28, which is 196, equals K squared. Take the square root of 196 is actually 14. So K is 14. In this case, they don't even ask you for R, so you don't need to go back and calculate R. What about C? C, let's see. K times R is equal to K plus 8. And K plus 8 times R is equal to 9K. So let's see. We could divide both sides by K, and then we'll get R equals K plus 8 over K. And then we could take the R and we could substitute it into here. So we'll have K plus 8, and then R is K plus 8 also, and divided by K. And that would be equal to 9K. Multiply both sides by K, we get 9K squared. And here we can multiply out the K plus 8 squared. We could get K squared plus 16K plus 64. And then we could subtract 9K squared from both sides. And that'll give us negative 8K squared plus 16K plus 64 equals 0. Oh, now that's kind of hairy to figure out. You can use the quadratic formula, but obviously you can factor an 8 out of this. So that maybe a negative 8, and that will give us k squared minus 2k plus 8. And I just got some of those signs wrong, didn't I? Okay. And then if we factor this, it would factor into that, right? So k could be equal to 4, or k could be equal to negative 2. All right. Take a look at example 9. Then you can tackle these. Find the general term un of the geometric sequence which has u4 equals 24 and u7 equals 192. So we would have un is equal to u1 times r to the n minus 1, right? So if you had u4, if u4 is equal to 24, then we could write u4, which is 24, is equal to u1, which we don't know yet, r to the, let's see, 4 minus 1, which is 3. And then for the u7 term, we could write 192 equals u1 times r to the 6th. And then we could figure out, we could divide both sides by 24. We would divide both sides by r cubed, and we get u1 equals 24 divided by r cubed. And then we would put it in there, and we get 192 equals 24 divided by r cubed times r to the 6th. These would kind of cancel out. You would be left with r cubed. So we would have 192 equals 24 times r cubed. We could divide both sides by 24. We would get 8 equals r cubed. So if 8 is r cubed, then r is equal to 2. Okay, so we know what r is now. To get u1, we could just substitute r equals 2 there. That would give us 24 divided by 8, which is 3. So now we know that u1 is 3 and r equals 2. Now we can write the general term as u of n equals 3 times 2 to the n minus 1. Okay, so that was the first one. And the next one says, okay, you got u7. Now I'm doing C. u7 equals 24, so it's 24 equals u1 times r, which we don't know yet, to the 6th. And u15 would be 384 equals u1 times r to the 14th. So now we could do the same thing. We could say u1 equals 24 divided by r to the 6th. We could put it in there. We get 384 equals 24 r to the 14th divided by r to the 6th. And that would be r to the 8th, right? And 384 divided by 24 is equal to 16. So that would be 16 equals r to the 8th. And the 8th root of 16 is square root of 2. So r is square root of 2. u1 is equal to 24 over square root of 2 to the 6th. Square root of 2 to the 6th would be 8. So 24 divided by 8 is equal to 3. So actually u1 is equal to 3 in this case. And so we could write the general term as un is equal to 3 times square root of 2 to the n minus 1. Okay, that was C. Now let's look at 10. A and C. Find the first term of the sequence 2, 6, 1854, which exceeds 10,000. Okay, so first we would find the general term. the general term would be un equals u1 times r to the n minus 1, but we do know that u1 is 2. We do know that r is 3 just from looking at it, and we know that n minus, well, we don't know what n minus 1 is. Now, un, we want it to be approximately 10,000, so we'll go ahead and put 10,000 in there. Now, we could just use algebra, and we'll figure out what n should be so that this works out. So we end up simplifying. We get 5,000 equals 3 to the n minus 1. Now, how can we do this without doing a bunch of multiplications by 3? Well, you remember logs, right? If we use logs, we can figure this out. So we could do log of 5,000 is equal to n minus 1 times log of 3. Remember that rule of logs? And so n minus 1 is actually equal to log of 5,000 divided by log of 3. And so we could calculate that here. So log of 5,000 divided by log of 3. 7.75. Okay, so actually, if n minus 1 is 7.5, that means n is equal to 8.75. So we would want the 8th term. The 8th term would be the last term, which would not exceed 10,000, and u9 would exceed 10,000. So u9 would be greater than 10,000, which is what we wanted to know, right? And if they want us to actually find the term, what is u9, then we could use the general term, right? u9 is equal to, and then we know that it's 2 times 3 to the n minus 1, which we know is 8. Okay, so we could do 3 to the 8th, 3 to the 8th, which is 6,561, and we multiply by 2. And it's 13,122. Okay? So you could have done that without logs. You could just like, do repeated multiplication on your calculator and find that, right? What about C? Find the first term of the sequence, 12, 6, 3, 1.5, which is less than 0.001. Let's use the method of just multiplication. So what are we doing every time here? We're multiplying by 0.5, right? So we could go 12, and then we could do times 0.5. Okay, and then so that gives us 6. So that was that's the second term, right? This would be the third term. I'm just hitting enter here. This is the fourth term, fifth term, sixth term, seventh term, eighth term, ninth term, 10th term, 11th term, 12th term, 13th term, 14th term. So we're getting really close now. Oh no, we need to go even smaller. 15th term, 16th term, 17th term, 18th term. Okay, so on the 18th term, we got there. So in this case, we were looking for the 18th term, which is 0.0000916. Okay, so that's the first term that's lower than 0.0001. And we just used repeated multiplication on the calculator to do that. But the other way to do it would be logs. You can see these problems you would need a calculator usually to do. Okay, number 1. A nest of ants initially contains 500 individuals. The population is increasing by 12% each week. How many ants will there be after 10 weeks or after 20 weeks? Use technology to find out how many weeks it will take for the ant population to reach 2,000. So let's see. The initially has 500, Population is increasing 12% a week, so that would be R equals, would it be 0.12? No, it would be 1.12. You have to add the 1 because it's actually increasing by 12%. So every week there's 112% of what was before, or 1.12. Okay, so how many weeks will be there after 10 weeks? So it would be U10 is equal to 500 times 1.12 to the 9th. And what about the other one? It's U20 is equal to 500 times 1.12 to the 19th. Use technology to find how many weeks it will take for the ant population to reach 2,000. So in this case you say, okay, 2,000 is equal to 500 times 1.12 to the n minus 1. Okay, so we could you could graph it, or you could use logs. Okay, so if we were going to use logs, we would say, okay, first we divide both sides by 500. It makes things easier. We'll have 4 equals 1.12 to the n minus 1, and then we'll just take the log of both sides. That will give us log of 4 is equal to n minus 1 times the log of 1.12. And so n minus 1 is equal to the log of 4 divided by the log of 1.12. And then you could just divide that out and add 1 to both sides, and that should give you the number of weeks, n. And it will be a little bit more. It probably won't be an exact whole number, but all you need to do is say, okay, round that up, because the number of weeks to reach 2,000 would be the whole number, the next whole number. Okay. The animal Erraticus is endangered. Since 95, there's only been 1 colony remaining, and in 95 the population of the colony was 555. The population has been steadily decreasing by 4.5% per year. Find the population in the year 2010. Okay, so here it says U1 is we don't know the population in 1995. Let's say 1995 is U1, would be 555, and then it's been decreasing by 4.5% per year. 4.5% decrease would be the same thing as 100% minus 4.5% for R, which is basically 95.5%, which is 0.955. So we do 1 minus 0.045 to get this, okay? So now we have what we need. If we're going to find what U is equal to in 2010, then you can see there's 15 years there. So instead of U1, it would be 15 years after U1. So that would be U16, right? So U16 would be equal to 555 times 0.955 to the 15th power. Okay. And so that, if you put that in your calculator, you'd be able to find the answer to part A. Part B, in which year would we expect the population to have declined to 50? Okay, then you would say, okay, 50 equals 555 times 0.955, and then we don't know what the year is. We're going to figure that out here, or how many years after 1995. And let's see, we would probably do this with logs, right? First we would try to make it less messy. Take the log of both sides. So we have log of 50 divided by 5, and that would be equal to 0.0901. And then on this side we have n minus 1 times the log of 0.955. And then so n minus 1 is actually equal to the log of 0.0901 divided by log of 0.955. And that will give us a value for n, and then we'll be able to figure out how many years it would take to get to a population of 50. A herd of 32 deer is left unchecked on a large island off the coast of Alaska. It is estimated that the size of the herd will increase each year by 18%. So what would be R? R would be 1 plus 0.18, which is 1.18, right? U1 is the initial population, which is 32. Okay, estimate the size of the herd after 5 years. So after 5 years would be U6, right? After 10 years would be U10. Okay. And, I'm sorry, U11 actually. So after 5 years would be U6, and that would be equal to 32 times 1.18 to the 5th. And U11, which would be after 10 years, would be 32 times 1.18 to the 10th. Okay, and we could do that on a calculator. Here's a demonstration of the 5th. That would be about 73. How long will it take for the herd size to reach 5,000? Okay, you would use logs for this too. But you would have 5,000 equals 32 times 1.18 to the n minus 1. We've done a lot of examples with logs, so let's do one with graphing. So we could graph the right side of this, 32 1.18 to the x minus 1. We put it here. And then we could, so we'll graph it. And then we can see that it is increasing steadily, and we can see it's going off the screen, so we need to adjust the zoom here. So we could do zoom, and we could do zoom fit, which is I think option 0 or something like that. Yeah. And then that'll help us see more of the function. Okay. And then we're interested in when does this thing hit 5,000. So in order to see where it hits 5,000, we could graph another line, which would be 5,000. Graph that. And I think that may be off the screen. So let's do zoom fit again. 0. Now it's gonna graph again, and hopefully it will. We can see the. Oh, and it's like way over to the right. So we need to actually move over more to the right. So let's put like maybe like change the window size, and we're going to change X max to like 150 or something. Okay. Oh, there we go. Okay, and there's the intersection right there. So then we could we could find that intersection, and that'll tell us what n should equal to. So we'll do let's see, second calc intersect first curve, second curve, yeah. Doesn't matter where we guess because they only intersect once. And there's the intersection, so it's at 31.5. Okay, so how long will it take for the herd size to reach 5,000? Well, it would be in U32. Okay, so U32 would be 31 years after. 31 years after. Okay. Last one. An endangered species of marsupials has a population of 178. With successful breeding, the program is expected to increase by 32% per year. So R is equal to 1.32 because it's 0.32 plus 1. U1 is equal to 178. Find the expected population after 10 years. So U1 is equal to 178. After 10 years would be U10. So it would be 178 times 1.32 times, it would be after 10 years would be U11, right? So it would be that. And then the 25 years would be U26. 178 times 1.32 to the 25th, okay? How long will it take for the population to reach 10,000? So that would be 10,000, and you could just use your calculator to calculate these others. 10,000 is equal to 178 times 1.32 to the n minus 1. Okay, and so let's do this another different way. So on the calculator, you could just do repeated multiplications. You could do 178, put that in, and then you go times 1.32. And so this would be after 1 year, after 2 years. I'm just hitting enter here. After 3 years, after 4 years, 5 years, 6 years, 7 years, 8 years, 9 years, 10 years. Now I just did 12 years. This will be 13, 14, 15. Okay, on the 15th year, after 15 years, it reaches 10,000. So it would be 15 years. So I just did that with the calculator doing repeated multiplications.